we will discuss about what is the X-ray diffraction. Okay. So X-ray diffraction, and there three methods are there, and for applying that three methods for diffraction of the any crystal, you can take the crystal, means that your material or the solid in the form of the single crystal. You take single crystal of that material, or there is another way. You have to develop single crystal of that. Single crystal means not one unit cell. A single crystal which has been developed by using different synthesis method, preparatory method, and that will have particular dimension of say 1 mm, 1 millimeter, or like that. So that either that single crystal you can take, or otherwise you can take the powder form of the material. Like you have to crush that powder, as the powder is crystalline, so you have to crush that powder, and then that powder form you can take the XRD, X-ray diffraction you can do. So depending upon the two, either you can take that single crystal, or you can take that powder form, or there are another, because this all condition, whenever you are using the method of diffraction, that one law should be obeyed, that is the Bragg's law. And for first order diffraction or first order reflection, when we take n is equal to 1, so for minimum reflection it will have the 2d sin theta is equal to lambda. So here if I say that here inside d is fixed, because it is within the that solid, we can't change it, whatever it is the characteristics of the particular solid, so we are not able to change that d, but we can change out from outside the two factors, that lambda and theta. So we can change here, either we can fix theta, we can vary lambda, or we can fix lambda, that is wavelength, and we can change theta by keeping d as a constant. And of course we can either take this powder form or single crystal. But in all the cases, this complete law should be obeyed. Means what? When you change theta, increase theta, lambda should increase corresponding, depending upon the condition, or whatever the condition, but the Bragg's law should be obeyed in that technique. So, and this normally technique is used in a structural analysis to find out what type of the crystal is there, what is the symmetry inside the crystal there. So for finding the interplanar distances, or finding the lattice constants, all that. So we can find out the first d value from this, and from the d value we can find the size of the unit cell as well as the distribution of the atom in the unit cell, how atoms are distributed within the unit cell. That we can simply study, and this not at this level, but when you go for say PhD, and that time you have to synthesize some material, any random material you are synthesizing, preparing by chemical reaction, and then you have to simply find out what kind of the structure I have formed by this method. So for that, simply you have to take the powder form of that material, and you have to give it for XRD, X-ray diffraction. So one pattern will be obtained in terms of the peaks, which will be plot of the I think lambda is fixed, so there d versus theta, interplanar distances versus theta. So that pattern is nothing but the X-ray pattern, and from that you can simply study that X-ray pattern, and you can find out the different factors from the given values of d. You can find out that the unit cell type, then distribution of the atom in unit cell, all that factors can be studied. So this is what the diffraction methods are there. Now there can have the three methods of diffraction. So that three methods, just I told, the Lovelace method, rotating crystal method, and powder method. So what is the difference between the three methods? Almost the technique is same. All three have to obey, or they have to simply follow the condition of the Bragg's law. But the difference is that when we are using Lovelace method, the single crystal is used and is held stationary. Means you don't have to rotate. Means the angle will not be changing. Okay. Here single crystal you have to take, and and it has to be exposed by X-rays. In the path of the X-ray, we have to keep the single crystal of that material, and you have to hold it stationary. In rotating crystal method, single crystal is used, but it is rotating. Means what is the difference between two methods? First case, you have to keep the crystal fixed in the path of the X-ray. Okay. In second, you have to keep it rotating. Now, in powder method, you are not taking single crystal, but sample is in the form of powder. You have to crush the given sample in powder form, and it has been kept stationary. It's not rotating again. Okay. Then, in single crystal, beam of white light, means monochromatic, not exactly monochromatic, but it is a variable frequency X-ray. Not of there are different kind of the X-ray, so the range of the wavelength will be incident, and this X-ray or white light. Sometimes white light means, but not that particular white light, ordinary light. It has to be X-ray only. So white light with a variable wavelength is incident on the single crystal, whereas monochromatic radiation of fixed wavelength is incident on the single crystal in case of the rotating crystal method. So this is the difference. In first method, Lovett method, you have to go for a variable wavelength. Every time you will be changing wavelength. See what above side we were keeping theta fixed, lambda we are changing in Lovett method. Here in rotating crystal method, you are changing theta, fixing wavelength. Okay. Third method, that powder method, you are taking the powder form of the sample and keeping it stationary, and wavelength is varied, not varied. It is a fixed radiation. Monochromatic radiation of fixed wavelength is incident on the single crystal. But here the number of the single crystal will be there in a powder form. Not of one, but number of the single crystal will be there. So D value will be automatically changing, because the number of crystal means automatically for each crystal D will be changing. So that will be the variation. Now in the first method, that Lovett method, glancing angle theta is fixed. Okay, just because we are keeping it stationary. Whereas in a rotating crystal method, glancing angle theta is varied continuously, and in third method, glancing angle theta is varied continuously. Means what here? Because your powder form there, no, so automatically for a different angle, different theta will be there. Though you are keeping it stationary, for different angle, a different plane, different theta will be there. So automatically the glancing angle will be varied there. Now different wavelength of white light diffract the fixed reflecting plane. Here in a Lovett method, as we are using the single crystal, planes will be fixed. So single crystal are they will be obeying the Bragg's law, means wavelengths are different but plane are fixed. In rotating crystal method, rotation of the fixed wavelength is incident on different sets of the parallel atomic plane. So automatically crystal is rotating means what? In the path of that X-rays, different plane will be coming, and as the different planes are coming, because of the fixed wavelength, they will be scattering. So that kind of the diffraction will obtain, and they will follow the Bragg's law. And in powder method, radiation of fixed wavelength, lambda is fixed, is incident on number of the small crystallites with different orientation. As we are in this is in a powder form, different plane are available there in a powder form, because we are not taking any single crystal, number of such crystal are there. Automatically, due to the fixed wavelength even, we will have a different diffraction pattern seen there. So these are the three methods we are using, or three techniques for the X-ray diffraction. That's Lovett method, rotating crystal method, and powder method.